Hello everyone. The topic for today's lecture is iteration. Quick reminder before we get started. If you're unable to take exam 1 next Monday during the provided 24-hour window period, please fill out the exam 1 conflict form by today, which is 17th Feb. Today is going to be a loopy lecture. That's because we are going to learn about while loops. What exactly does a loop enable us to do? Loops enable us to repeat certain steps for a certain number of times. There are two kinds of loops in Python, while loops and for loops. As part of the next two lectures, we are going to learn about while loops. After exam 1, we'll learn about for loops. In today's lecture, we are going to learn the syntax for while loops. Then we'll understand common use cases for while loops. We'll be learning how to avoid common pitfalls like infinite loops and off by one errors. The reading for this particular material is chapter 7 of Downey book. Please make sure to go through that. Let's get started by revisiting the factorial computation problem that we covered as part of the pseudocode lecture. Combination of conditionally skipping forward with going back is called as a while loop in programming world. What exactly is the condition here? That would be if n equals 1 as detailed in step 2. The going back part is step 5, which indicates that we should go to step 2. The steps which we want to repetitively execute are going to be called as the loop body, and the condition itself is going to be called as the loop condition. The going back part is implicit in Python, and it will happen right after the lines of code within the loop body finish executing. How can we identify the lines of code within the loop body? The lines of code within the loop body will be indented. How do we know the number of times that we repeat execution for the loop body? Well, that depends on the loop condition here. As long as the loop condition keeps evaluating to true, we'll continue executing the loop body. Immediately after the loop condition evaluates to false, we are going to skip past the loop body and we'll be done with the loop execution. Let's understand the concept of while loops using a control flow diagram example. In this example, we are getting user input for the variable x using the input function call. Recall that the input function call always returns string type. We need to explicitly typecast that into the data type that we need. In this particular example, we are using the float typecast function to convert the string type inside the variable x into floating point type. Then we are reassigning the converted floating point type back into the variable x. Then we have a condition represented using the diamond here. The condition is checking whether x is less than 0. When the user enters a negative number, we are simply going to display need a positive and exiting. If the user enters a positive number, we'll be displaying the square root of that number by calling the square root function inside the math module. Wouldn't it be nice if we can keep prompting the user to enter the correct input for this particular problem? While loops are going to enable us to do that. Observe that the rectangular box here changed slightly. Other than just displaying please try again, we are now calling the input function call to prompt the user to enter the input for the variable x. Then we create a cycle by doing that. The cycle is going to be called as loop. Every time we execute the loop body is going to be called as an iteration of the loop. The number of times the loop body gets executed would be the number of iterations for that particular while loop. The diamond condition here is going to be the loop condition, and the rectangular box where we updated the code is going to be the loop body. We keep executing the loop body while the condition is true, so it's called as the while loop. Think about what would happen if we were to strike out this line of code here? Please pause the lecture video here and answer this question. What does this loop do, assuming that you're removing the input function call from inside the loop body? If you were thinking that the program will run forever, then you had the correct answer to my question. This is something which is called as an infinite loop. To avoid infinite loops, we need to make sure that we are updating the loop condition variable inside the loop body in such a way that we are able to eventually turn the loop condition to be false. We'll be covering demo problems to understand this particular concept. Let's first learn the basic syntax for while. Here is an example which uses an if condition. In this example, we are getting user input for X and we are typecasting the user entered input into an integer. Then we have a conditional which is checking if the user entered a negative value. If so, then we are just prompting the user one more time here saying please try again. With the current version of this program, the user can at the maximum enter 2 inputs, correct? How can we change this to make sure that we repetitively prompt the user for entering the correct input? We can just replace the if keyword with the while keyword. That pretty much is the syntax for the while loop. You'll have while keyword, then Boolean expression, then a colon, and then you have the loop body which is indented block of code here. We can just like that replace the if keyword with the while keyword in this particular example to keep giving the user an arbitrary number of tries until they get the correct input. Let's use another diagrammatic visualization to understand the concept of while loop. The syntax for while loop is going to be while condition colon, and let's assume we have some lines of code within the loop body. After the loop body, we are going to have more lines of code. How can I say these lines of code are after the loop body? Observe that the lines of code after the loop body line up with the while keyword in terms of level of indentation. Let's understand the control flow aspect of a while loop. Every time you run the while loop, your condition is going to be evaluated. As long as your condition is true, you're going to execute the lines of code within the loop body. Immediately after you're done executing the last line of code within the loop body, you're going to go back to the condition and check it one more time. As long as the condition keeps evaluating to true, you'll keep executing the loop body for however number of iterations that particular condition makes the loop to run. Immediately after the condition evaluates to false, you're going to skip past the loop body and you're going to execute the lines of code after the loop body. Let's go through the detailed steps that you need to follow whenever you're writing a while loop. There are two major steps. Step number one would be to make sure that you initialize your loop condition variable to some value. And step number two has two sub-steps. Part A is about updating the loop condition variable in the loop body. You don't just have to make any updates, but your update need to make progress towards eventually turning your loop condition to become false. We'll go through a couple of examples to understand these steps over here. Let's take a minute to congratulate all of you here. You've learned all the aspects about control flow. The basic concept in control flow is in order execution, where you proceed forward executing one line of code at a time. We went through three exceptions for in order execution. The first exception would be functions. Functions are mini programs where your execution jumps directly from the line where you're calling the function to the line where you have defined the function, which could be anywhere above the line where you're calling the function. The second exception for in-order execution will be conditional, where you execute certain block of code when the condition evaluates to true, and you'll be executing some other block of code when the condition evaluates to false. The block of code or the path that you follow when the condition evaluates to true is called as conditional execution, and the other path that you follow is called as alternate execution. The third exception for n-order execution will be loops, where you repeat certain steps for certain number of times depending on the loop condition. Let's go through basic demos for while loops. I'm going to switch to my Chrome browser. I have the course website open. I'm going to click on Tools and Python Tutor. Let me click on Live Programming Mode. What I want to do now is to initialize a loop condition variable. That's going to be step 1, correct? So I'm going to initialize a variable called count with a value of 0. Let me outline the objective of this particular problem. Let's say that we want to count from 0 to 3, printing each number. Let's start typing the while loop for that. I'm going to type the keyword while. Then we have to type the Boolean expression. Since we want to count from 0 to 3, I'll have to say count less than or equal to 3, correct? Then I'll have to type in a colon. Let's say that within the loop body, I only call the print function call to display count. The very first example I'm showing you here is an infinite loop. We'll soon talk about how to avoid this. Let's first go through what's happening here. We're getting some kind of an error here saying that the program execution stopped after running 1000 steps. Observe that you're getting too many zeros in the display output box here. What happened here is that we did not follow step number 2, part A, correct? We did not update the loop condition variable inside the loop body. Let's make sure that we fix that. Since we start at 0 and we want to go from 0 to 3, we want to increment the loop condition variable of count by 1, correct? So I'm going to do that by saying count plus equal to 1. I'm using the syntactic sugar plus equal to shortcut. Observe that now we are getting the display output as 0, 1, 2, 3 here. Let's step through this particular program from the beginning. I can do that by clicking on first. We create a global variable called count, which is going to go into the global frame, and we initialize the count variable to a value of 0. So we satisfied step 1 from the slides. Going back to the slide which has the steps here, we took care of initializing the loop condition variable. Then what are we doing next? We begin the loop execution. Immediately after the line of execution reaches line 4 here, Python is going to evaluate this loop condition. Count is holding a value of 0. 0 is less than or equal to 3. So you're going to proceed with executing the loop body. So you'll display 0 next. And then you're incrementing count by 1, which is going to change the value of count to 1. Then you go back to line 4. Observe that the red arrow went from line 6 to line 4. 1 is less than or equal to 3. So you're going to display 1. Then you're going to increment 1 to 2. Then you go back to line 4 again. 2 is less than or equal to 3. So you're going to print 2 and you're going to increment 2 to 3. 3 is still less than or equal to 3. So you're going to display 3. What happens now is that 4 is not less than or equal to 3. Observe that the execution still went back to line 4 because you get one more time evaluation of your condition than the number of iterations. So that's why the red arrow went back to line 4 here, and you're going to evaluate the loop condition one final time. 4 is not less than or equal to 3. So the loop condition will evaluate to false and you'll be done with the program execution. So if I add a print function call to display all done here, and let me change the execution of the loop from 0 to 2, say, to make it quicker. I'm going to really quickly step through from the beginning. So we have the various iterations of this while loop here, and as soon as your counter becomes 3, your loop condition here is going to evaluate to false, and your next line of code will be line number 8, and you're going to display all done here. Let's convert this requirement slightly here. Instead of counting from 0 to 3, let's say that we want to count from 3 to minus 3. Let's consider how we need to change this particular loop here. So we are going to initialize our loop condition variable to a value of 3, correct? What do we want to do next? We want to count from 3 to minus 3. Think about how you need to change your condition here. You start with a value of 3, so you want to go until minus 3. That means that your condition here should be greater than or equal to minus 3, correct? Observe that we are getting another infinite loop here. You can see that by seeing this error which says stopped after running 1000 steps. Why did we get an infinite loop? That's because we did not make progress in the correct direction towards turning the loop condition to become false, right? Let's try to understand that. So you're initializing count to 3. You're checking that count is greater than or equal to minus 3. 3 is greater than or equal to minus 3. Then you're printing count, which will print 3. Then you're incrementing count by 1. So 4 is going to be the next value for which you evaluate the condition. 4 is greater than or equal to 3. Then you print 4. Then you're going to increment count by 1. What's going to happen then? It's going to get incremented to 5, correct? So let's just step through the program steps here really quickly. So count is 3, you display 3, and then count gets incremented to 4, you display 4. Count gets incremented to 5, you display 5. You see the problem here, right? Your condition will never turn false because you keep incrementing the values. The objective here is to display the values from 3 to minus 3. So clearly you'll have to decrement the values, and looks like we are getting the values from 3 to minus 3 here, and then you get all done, which seems to be the expected output for this program. You need to always be very careful about off by 1 errors with loops. Let's say that your condition here is incorrect and you have count greater than minus 3 instead of count greater than or equal to minus 3. Observe that now the output is only displaying 3, 2, 1, 0, minus 1 and minus 2. That's because you set the Boolean expression to be greater than 3 and not greater than or equal to 3. Let me switch to my terminal window. I am right now in lecture 11 directory inside my favorite documents directory. Please make sure to launch idle editor in between this video and the next lecture video. We are going to go through a demo problem where we are going to write code inside a script file called alarm.py. I'll wrap up this video here. In the next video, we'll go through the demo problem for alarm.